Hello and welcome to this chapter lecture. We're going to discuss chapter 12, Information Systems and System Development. There are 6 learning objectives in this chapter, and we will touch on all 6 of these in our presentation here. So the first one is understanding what information systems are and what's needed. So the first learning objective is, what is an information system? The classic definition of an information system is the 5 elements working together: people, software, hardware, procedures, data, those 5 things working together. It's important to realize that an information system is not just a piece of technology. It's how the technology is used. That's what we mean by the procedures. It's the data being processed by the technology, the value of the outputs related to the value of the input, the data that you put in, garbage in, garbage out, quality in, quality out. And the hardware and software are part of the system, but it's how they're used. They're used strategically for a purpose. And the role of data has always been in this chart. This basic 5-element definition of an information system has been around for decades, 2-3 decades. We've had this, but there's so much more data available now, and the hardware and software is so much cheaper, smaller, faster, and able to process that data that we're gaining more insights now than we ever have. The value of an information system within an organization is increasing over time. Some terms that are introduced in this chapter that are probably that I want to make sure that you see in the lecture. I know you're going to read the chapter and get exposed to more of these, but business intelligence, the process of gathering, storing, accessing, and analyzing data in order to make better business decisions. The idea here is that it's applied to business, that there is a business use for thinking about intelligent systems. Business analytics, this is a process of analyzing data to evaluate a company's operations. These are very similar objectives, business intelligence and business analytics. And you can study computer intelligence and you can study data analytics outside of the context of business. They do it in healthcare, they do it in biology, they do it for human genome sequencing. You can do it in a number of disciplines. But when you start taking data and making analysis of data and intelligent decisions based on that analysis, then you're in the field of business intelligence, business analytics. Data warehouse, that's a term that we use to refer to a collection of so much data that an organization has. That data is a company asset. It's an important company asset. And it used to just be the data that you worked with is very small. It fits on somebody's desk. It fit in a file folder. Then it became electronic and it worked, fit on a small computer. Now the data that we have is so massive for an organization that conceptually we talk about it as a data warehouse. It's not a physical warehouse. You don't physically build a structure for it. It still exists on a server or on the cloud or something, but we use the term data warehouse to refer to how much data is available to the business for intelligence, for an analysis purpose, and intelligent decision making based on that analysis. Data mining, this is a term that again has been around for a long time, but as data is getting bigger and bigger and bigger and more useful, the field of data mining is becoming more and more important to businesses. 2 classic examples are the grocery store analogy, the fact that a grocery store might realize that there's a relationship between diapers and beer sales for a given customer, and you could arrange your store so that from the time you buy the diapers until the time you check out, you pass by the beer aisle. And the legend of the data analysis there is that happened and the store saw an increase in their beer sales just by repositioning some of the products in their store. Stores do this, absolutely. Milk is in the back of a store for a reason, because customers go to get milk, but once they get to the store and they have the milk, they will just see other things on their way toward the front. There is an art to the design of a grocery store, and data analytics can help a store design their layout better and make more profit. There's also the real story, which is not fictional in any way, where Target was using data analytics of customer sales purchases to predict other products that they would be purchasing in the future. And one of the things that they ended up realizing is that young women or older women, whatever age, who bought certain products would be more likely to buy other products in the future. And those other products happen to be things like baby wipes and neonatal vitamins, and know what to expect when you're expecting book, get a discount on that. Things that clearly indicated that a person was pregnant. So they were sending coupons out that clearly were targeted to a pregnant person. and one of the receivers of these coupons was a young woman still living at home with her father. The father saw the coupons, was very shocked to see Target promoting premarital sex and all those things with her daughter, called the store, got very angry, had a conversation with his daughter, found out that she actually was pregnant, and had to call back to the store and apologize for overreacting. Target changed their policy so that they no longer just use that information to be so clear and specific. They still send the coupons out, but now they have other things as well, so it's not clear if a dad receives a set of coupons for his daughter, and there might be some pregnancy related coupons in there, but there's also coupons in there that have nothing to do with pregnancy. There's coupons in there about Halloween candy. There's coupons in there about new clothing for the season. There's coupons in there about sports apparel. So you can read online about Target and its data mining, but it has value, and companies are doing it because data is a useful business asset, and there are tools and techniques that you can learn and you can use, that individuals in an organization can use to be more effective and make better decisions. Business intelligence. Our book talks about a zoo as an example of using business intelligence. I just kind of like that example because it gets to see a picture of a polar bear and makes you think about times that you've went to a zoo, if you've gone to a zoo, but also just to realize that you don't think of a zoo as a business that's going to be using data analytics to make more money. But zoos are doing that. They're looking at the exhibits they present and how it affects box office and how it affects where the customers spend their time in the park, and they are making informed decisions about the animals that they borrow from other zoos. Turns out you actually can't buy and sell animals. Zoos rent the animals and have a bit of a bartering system where they say a giraffe is worth 2 polar bears or 5 penguins or whatever it is. So there's a whole market that that exists within zoos because they're not allowed to actually buy and sell the animals. The point is that every business, including zoos, use data to make informed decisions. At least smart, modern 21st century businesses all use that data. There's so much data out there. What about the data that's outside the organization? What about just the end users and the things they're saying on Facebook and the things they're saying on Twitter and the websites that they're visiting and what are you doing on our website? When you go to our website, which pages on our website are you looking at? How much time are you spending on a given page on a website? All that information is out there, and people are realizing that there is business value in knowing that information and making informed decisions based on that information. So there are tools that allow you to work with and analyze the data of social media and user behavior on your website and other sites. Wouldn't it be great if you, as a business professional, knew some of the tools and some of the techniques that were making businesses profitable and helping businesses make better decisions? Well, if you have such an interest, I would strongly encourage you to get a business informatics double major here at Western Kentucky University. If you're a management major, you should be a management and business informatics double major. If you're a marketing major, you should be a marketing and business informatics double major. If you're an accounting major, I suggest that you should be an accounting and a business informatics double major. If you're an econ major, I suggest you should be an econ and business informatics double major. If you're a finance major, I suggest you should be a finance and business informatics double major. I think I mentioned all 5. If I left one off, you should be that in business informatics. It only takes 6 additional classes, in some cases only 5 additional classes, to get a double major in the College of Business with whatever you're currently majoring in and business informatics. And in those 5 classes, you will work with some business analytics tools. You'll learn some techniques on how to process data and display data and come up with results and analysis and insights based on data that can help you be a better manager, marketer, finance, economics person, or accountant within your organization. And you'll be better prepared to speak the language of 21st century business. So I strongly, strongly encourage you to be a double major. Okay, there are 6 learning objectives in the chapter. Learning objective number 2 is who uses information systems, and this is, I'll be a little shorter here, it's everybody. Right? And what this chart shows us is that everybody in the organization uses an information system. There are information systems that are targeted for the people at the top of the chart, the president and the CEO, CFO, the CIO, all the C-level executives in an organization. They have more strategic level information system tools that they use. There are tools for the managers and the middle managers that they use. There are tools for the people who do the brunt of the work within the organization. At the lower level they have of the organization, they have tools that are specific to them, to the point of the cash register at McDonald's, who has a point of sale POS terminal where they just sit and type, hamburgers and Big Mac and shake, and you're typing it in. It's specially designed for McDonald's. That point of sale device at the McDonald's register would not work at another, even another fast food restaurant, even another burger joint fast food restaurant, because it's got the items on it that are specific to McDonald's. It's customized and tailored, and that data is used to route immediately to the cooks in the back and to the order line and to all the things. I mean, it's an integrated, tied-in system that everybody uses in the organization. Now, there are some systems that span the entire pyramid of the organization. They affect the person who's first day on the job at the company, and they affect the person who's been there 20 years as at the C-level suite executive at the company. Those are called enterprise systems because they cover all the professions, and they also span horizontally across all the silos: finance, marketing, economics, management, and so on. Who uses the system? Again, enterprise systems are used by everybody. Decision support systems are used by middle managers and higher level people. Operations people at the lower end do the brunt of the work. They have their own specialized systems that are going on there. Types of information systems. So this is our third learning objective from the chapter. And again, I'm going to leave this to you for the reading that has lots of graphics and images, and you might find some things that are interesting to you. Suffice to say, there are a lot of different technologies that are used in a 21st century business. That probably shouldn't shock anybody. In the 1800s, you probably didn't have a lot of technology, certainly computer technology and data available to you. It was, here's the way we've always done things. It's the human expertise of the guy who's done the job for 20 years, and he's training his apprentice, and the apprentice is learning how to do the job. That's not the case in 21st century. In case of 21st century, we have a lot of tools, a lot of technology, a lot of data that informs the decisions and the actions of the organization. And these tools span the entire organization. What I will point out is this bottom thing, artificial intelligence. Our book in chapter 12 talks about artificial intelligence for a little bit. This is personally an area that I'm interested in. I have a PhD in artificial intelligence from Vanderbilt University, and it's something that I enjoy reading about and find very fascinating. So let me just limit my discussion now to what the book says about artificial intelligence, and then maybe in class we can talk about some things that the book doesn't say about artificial intelligence. Artificial intelligence, the idea is to do human things. Right? It's actually hard to define artificial intelligence, but the general gist is that things that humans do that machines can't do. Well, what if we made machines do those things that humans can't do? What if we gave them the intelligence necessary to do things that intelligent humans do, like playing chess, like playing Jeopardy? There was a time when playing chess was something that they never thought computers would be able to do very well, and computers eventually played chess better than the very best humans. There was a time when playing the game of Jeopardy, because of the types of questions and the wording of the questions and the trickiness of what's said and what's not said, they thought that would never happen, and turns out that computers play Jeopardy better than the best humans play Jeopardy. So what does it mean to be intelligent? Well, one of the questions there, that's an age-old question since we started talking about can machines think, and that was when we had our first machines, we started asking that question, can machines think? And one of the pioneers in computer technology, Alan Turing, who wrote a computer during World War II to break the Nazi codes, as documented in the excellent movie The Imitation Game, which I highly recommend. It was top secret research that didn't get revealed to the world until I think the 70s or the 80s. So people did not realize what a genius Alan Turing was in his efforts to build this computer that broke the code of the Enigma machine of the Nazis. But even separate from his top secret research, he still made a name for himself and was outstanding, was still one of the fathers of the field of computing because of some of the research he did on the theoretical limits of computing, which led to could machines ever think? And he was considered to be the grandfather of artificial intelligence. He proposed something called the Turing test, which is to say, could a machine ever have a conversation with you in such a way that if all you could see was the text messages you were getting back and forth, that you could not tell that you were talking to a machine, you were actually talking to a person. And Alan Turing thought that that would happen by the year 2000. Turns out it hasn't happened. There's an annual contest called a Loebner Prize contest where they try to pass this exam, and they never have passed it yet. Computer programs haven't actually gotten super close to that. But our book talks about that Loebner Prize, and I actually entered that contest when I was a graduate student at Vanderbilt and came in second place, so hooray for me. Types of AI systems. Expert systems are discussed in the chapter reading. The idea behind expert systems is that you can capture human expertise in a machine environment. And you think, well, a doctor is a medical expert. And I can't be a doctor, not without years and years of training. I certainly wouldn't expect my desktop computer to be able to know the things that a doctor knows, but it turns out your desktop computer can know the things that a medical doctor knows. Expert systems have been around and exist in industry in a variety of domains, medical domains and some business domains when it comes to doing planning of plants. I've seen expert systems that were in the field of repair of airplane systems. Right, there's a number of expert systems out there. There's expert systems out there for determining if a mortgage is going to be likely to default or not, and should you give a mortgage to a person from a banking perspective. So expert systems are real. Expert systems have been out there. They've got human expertise captured in something called a knowledge base, where you capture not facts and formulas, but rules of expertise, and then something called an inference engine that is the interface, the user interface between the human user who's asking the queries and trying to get insights from the expertise, and the inference engine knows how to go to the knowledge base and pull the right piece of information out based on the query of the user. Neural networks are discussed in our chapter. The idea that we can build a program that models the neurons of the brain. Now, the human brain has far more neurons than any neural network we've ever built. Even a tiny element of a rat brain has more neurons than we've built in a computer neural network. But the way the neural network is set up is that they use positive negative reinforcement to learn from their experience, and a computer-built neural network can learn. It's how we do such things as learning your fingerprint or learning your voice, that they modify their behavior over time. So there is something called machines can learn, in the sense that they can modify their behavior in the future based on their experiences in the past. So machine learning is something that's real and does exist, and one way of achieving that machine learning is through neural networks. The scale of the learning is nowhere on the scale of human brains or even rat brains, but there is behavior that modifies over time. An interesting topic, you can read some more about that on Google. You might find it very interesting. Maybe we'll talk about it in class during some digging deeper. We also talk in the chapter on artificial intelligence about intelligent agents. This is probably what we're familiar with, having something like Siri on our phone that's reminding us of events coming up that we may forget about, that is able to answer certain voice queries, so I don't have to go through a traditional type user interface. I can just say, is there any restaurants in the area when I'm in a new town for business or pleasure? I'm visiting a new town on vacation or on a professional meeting, and it's lunchtime and I'm hungry, and my phone would not only be able to use GPS technology to know where I am and what restaurants in the area, but it also might know my food preferences, and it also might know my friends, what they have rated on Yelp or some similar type of a program, restaurants in the area, that I like their taste in other restaurants, so I could use them to influence my restaurant, my taste here. So I just say to my phone, hey, are there any restaurants in the area? And it can give me some really good advice. There are an increasing number of uses of intelligent agents that are specific to a purpose that you want to do, and they are able to help you in that specific task. And robotics is discussed in this chapter. Now, robotics is kind of a field of artificial intelligence, but it's more on the hardware side. Everything we had previously talked about was on the software side. Robotics from the hardware side, we're talking about the ability to give movement and real-world interaction through arms, through levers, through wheels, through legs, through eyes, cameras that work as eyes so it can sense where it's going. And this is definitely a field that is getting big as well. The reason it's in the field of artificial intelligence is because we're trying to not just build a robot, but we're trying to give the robot some functionality to make it an intelligent agent. So this hardware of robotics is being combined with software development at the same time. From my personal perspective, I find the software development behind the robots to be much more interesting than just the physical elements of the robots. We've had robots in manufacturing for decades, but the robots are becoming much more interesting in manufacturing, not because the hardware is getting that much better, but because the software is getting that much better. Some areas where we're seeing robot use, toys and robots that sweep your floors or even mow your grass. There are YouTubes out there that you can read about these. And again, the most interesting robots you're going to see are the robots that have some interesting software behind them rather than just their functionality. An example of this is the software that drives auto-driving cars. So we've got sensors on the cars that's able to see in 360 degrees. It's able to actually see better than you and I see as a human driver with just two eyes and limited focus. We can't see behind us and in front of us at the same time. A driverless car can see in front and behind in all degrees faster than we are. A driverless car is going to respond faster to a child jumping in front of the car than you and I will. Won't be distracted by a text message and all those things. But we've had cameras. What's interesting about driverless cars is the software behind it that's making this possible now. Okay, quick quiz number 1. We've done the first 3 learning objectives in this chapter. Here's our first quiz. A system using knowledge from medical experts that is used to help diagnose patients. That would be an expert system, which is letter C. Yes, letter C. Number 2, true or false? Social media analytics refers to mining and analyzing data from blogs and social media websites. Yes, it is. It's kind of a new, relatively new opportunity within businesses to be making analytics based on customer social postings and community and postings of people who aren't your customers yet, but still have an opinion about products in your business area. Number 3. A blank is a device controlled by a human that can move and react to sensor input. That's one definition of a robot. Okay, learning objective number 4, only 4, 5, and 6. We're over halfway through. Responsibilities for system development. So what if we have to write a system? And software development, you may think, well, I'm never going to write a software. I have no desire to write software. But you can still be involved in the development of software even if you're not a programmer. Let me explain. One of the roles is a systems analyst, and a systems analyst is different than a computer programmer. A systems analyst studies the problem, talks to the customer, talks to the clients, knows the possibilities, knows the options on how it's going to be developed, and helps inform the decision and guide the decision. Other personnel used in software development include business analysts, which is similar to a systems analyst, but you're looking at even more from the business perspective, the opportunities, the threats, the weaknesses. A knowledge engineer, a term for a person who has expertise in a certain area of the application being developed. Multimedia developer, if we're talking about any kind of a user interface, any kind of a web presence involved with it. Operations personnel, security specialists. There's a whole list in the book. In fact, if we flip and look at some of these terms here, there's a number of persons working within the organizations that have jobs that are related to the power and benefit of a piece of business software, and even helping revise or define that business software that aren't hardcore computer science programmers. And you can fit into one of these. These are all very 21st century, high paying, high reward critical component of the organization moving forward. Here's some more terms that we see, computer-related terms. There are jobs associated with these as well. So knowing your technology and knowing your business area are two things that you can do that will really help yourself as you not only interview for a job, but as you get your first job, are successful at it, move on to your second job, or successful at that, and move on to your third job, where you're starting to get your best pay incentives. Moving through job to job is the best way to get a raise. Outsourcing. Technology is making it possible. This is a possible downside of technology. Technology is making it possible to get another person at a remote location to do the work for less, or to get a machine to do the work that you were paying a human for less than you were paying the human. Anything that is repetitive runs the risk of being outsourced by a human worker doing it for less, or by a machine doing it for less. You want to be creative and original and human in your efforts and time. The more you are automated and repetitive, the more likely you are to be at risk of the value of what you do being driven down because of competition, other people willing to do it less and able to do it less because of technology at remote distances without having to physically be on the campus, or technology itself doing the job through robotics, through software. Okay, so be aware of your personal interests, your personal expertise. Develop your personal interests, personal expertise, and look to jobs that look for opportunities to work with groups, look for opportunities to be involved in something innovative and creative, to be on committees and subcommittees that are doing something innovative. You want to emphasize and flex your personal and personality interests and traits as much as possible, because that's going to help. Some of the terms related to outsourcing, offshore, which means the job is done by another person who is off the shores of your country, in another country, which is different than nearshoring. The jobs are done by somebody outside your organization, not there on your physical campus, but they might just be in another state, or they might even be in the same state and in another town, or the same state in another town, but just working from home, not having to physically come to the plant, to the office to do the work. Telecommunication is kind of related to this as well. On the positive side, you can do your job without having to be in the office 40 hours a week. Sometimes we're seeing more and more of this telecommunication impacting, but it also means that, well, I can get somebody else to do the work, so it's having a price pressure. Home sourcing, outsourcing to home-based workers is what we were just talking about there as well. Which term refers to outsourcing work to another country? That would be offshoring, letter B. True or false, the IT worker who codes computer programs is called the computer operator. That's false. That would be the computer developer. But again, there's a long list of terms and jobs associated with developing a system. The IT employee most involved with system development is the systems analyst. Learning objective number 5, we talk about the software development life cycle. Software is not something that gets thrown together in an afternoon or a week. And it's not something that gets put together by a single individual. Maybe an app for a game or something on a phone might get developed by one person in a short period of time. But from a piece of business software, it involves a number of people working over an extended period of time. And they do it systematically. There's a step here. The software development lifecycle, SDLC, is a series of steps. Our book defines 6 steps. Some books have 5. Some books have 7. Right? But there's a series of steps. And the first step is a preliminary investigation. Before you get started, you start saying, is this something that's even going to be profitable? Even if we could develop it, would it be worthwhile when we get finished? The worst thing you want to do is spend 6 months developing some piece of system software, and then you get it built, and it's like, nobody uses it. It's not helpful. Why are we doing this? Right? You want to build something that when it's said and done, somebody in the organization, hopefully multiple people in the organization, or customers or clients, are going to say, hey, I'm glad you built this. This is making my life better. I want to use your product, or I want to help you produce your product at less cost, or whatever it is. Okay? So an initial investigation, and then we get into the systems analysis stage. That's where we're going through and we're really breaking it down onto pencil and paper. It's kind of the equivalent of drawing a blueprint. All right? So you don't start building a house until you have a blueprint of the house you're going to build. That's what systems analysis is. includes. Now, you don't physically build blueprints, but you do create charts and tables and graphics and use cases and a number of different tools that you can do to just think through the program, think through its implication, think through the people impacted, think through its functionality before you actually build the thing. That's what a blueprint does. You want to think through the house. You want to think through where's the wiring going to be, where's the water going to be, what are we doing about the plumbing, what are we doing about sewage, what are we doing about air conditioning, what are we doing about all the things. How high do the ceilings have to be? You want to think through all those things before you pour the concrete for a house. Same thing with software. Before you write your first line of code, you want to have thought through exactly what its functionality is going to be. The system design is where you flesh that out. You go into more detail about each of the drawings, each of the use cases, each of the designs, and you make sure that it's realistic and can be done. Our book talks about systems acquisition number 4, which is to say, now that we really know exactly what we're doing, do we want to build this ourselves, or do we want to see if there's a piece of software out there by some third-party provider that does what we want to do, or do we want to write it ourselves? So in that sense, it might be late in the game that you decide as part of your software development lifecycle that we're not going to build anything. We're going to find a third party that will build it for us to these specifications, because we have detailed specifications at this point, and we can outsource it, do a request for proposal, RFP, and find somebody that will develop it for us, or we can develop it ourselves. That's step 5, system implementation. Some books would just say system implementation comes next, and part of the system implementation is an internal decision about build versus buy, but our books did it separately. It's fine. When you get to the system implementation stage, the actual implementation of the detailed designs is only 15% of the time, effort, and money of the overall project. So the writing of the software, whether it's done in-house or externally, is usually only about 15%. The time, effort, the other things, the things we were just talking about, those first 3 steps, and then finally the systems maintenance, the last step, that ends up being the bulk of the time and effort. And what is maintenance? Well, after you write the software has a long lifetime. So here's those same, those big 4, the preliminary investigation, systems analysis, systems design. Those end up being our big time sinks, money sinks, effort sinks, people, creativity, right? And then the maintenance. Once you write a good piece of software, it has a long lifetime. Everything you do as a student has a lifetime of days. You write a research paper and then the teacher grades it and it's kind of gone. Right? And even if you were a software developer, if you were taking computer science or taking a programming class in business information, business analytics, we take a decision support class that I teach and we're writing software for there. That software has a lifetime of days. From the time you finish writing the software until the time that I grade it and give you a score back for it, at that point you probably never revisit the software, and I probably never revisit the software. That's the mindset of schoolwork. But in industry, software lives for decades. That's why we had the year 2000 problem. There was programs written in the 1960s and 1970s and 1980s that used 2 years to represent the date, the year. All right, so they used, instead of saying 1976, they just saved that year as a 76, and it implied 1976, right? Because what else would it be? I mean, it's clearly not 2076, and it's clearly not 1876. So all you need to know is the current year is 76. Well, that same software was still being used 10 years later, 20 years later, almost 30 years later, as we're coming up on the year 2000, and that's what triggered the year 2000 crisis. We had millions and millions of lines of code that was decades old that was using 2 digits to store numbers, and they had to go through and fix all that. So you can read about the Y2K crisis. People thought it was going to be a terrible thing. People thought not the world was going to end, but that there were going to be serious repercussions. Turns out there weren't, mainly because of the efforts of people to upgrade those systems, to fix those systems, or actually to upgrade those systems. There was a big boom in sales of technology. People really switched over systems to newer systems, and we saw a big bubble of IT there in the late 2000s because of that IT crisis, Y2K crisis. System conversion. Okay, we've built a new system. Now we need to roll it out. How do we roll it out? We've got our old system running on my computer and your computer and all the computers within our organization, and we want to have the new software running on those. You think, well, that's easy. You just roll it out. You just switch over. Well, it turns out there's actually some options there. You could do just a direct conversion where just on January 1st of of next year, everybody's going to put the new software on the machines and get rid of the old software. Or, not January 1st, say on Friday of this week, we're going to switch over from the old software to the new software and do it company-wide for every machine everywhere. Or what you might do is you might do a parallel conversion where we say, okay, we're going to, on Friday of this week, we're going to install the new software on our systems, but we're going to leave the old software running, and we're going to do the work in parallel. We'll actually be a little bit redundant. We'll do it on the old system and the new system, but as we're doing it, we'll make sure we get the same results on both systems. And then when we're confident that the new system is working, then we'll phase out the old system. That would be a parallel conversion. And you could do other things with a parallel. We have it on both machines. You might say some people are using the new system, some people are using the old systems, but you have it as a fallback. Even more complex, what happens if we have the software is more than just a single program? It's actually got modules. You might do a phased conversion where you do one module at a time, make sure it works, okay, good. Then do the next module, make sure it works, okay, good. Then do the next module, make sure it works, okay, good. And then once you've brought in all the modules, you are at that point running the new system successfully. And a fourth system conversion option discussed in our chapter is pilot conversion. The idea here is that we may pick a site, and this could be a department within the organization, or it could be a physical site, the New York office, the Kansas City office, the Nashville office, and we're going to, on that site, use the new system, but on the other sites, we're not going to disrupt their normal routine until we're sure the Kansas City office is able to use the new system successfully and people understand it and all the training works and everything else. And then we'll say, okay, now let's do the Nashville office, then the New York office, and so on. And the last learning objective is the approaches to the software development. This is not the this is pre-phasing it in. This is going back to the development itself. Our 6 phases: preliminary investigation, systems analysis, system design, systems acquisition, system implementation, systems maintenance, 1, 2, 3, 4, 5, 6. The classic model is something called a waterfall model, and that's a term that you will probably hear on the job if you ever talk about developing software. And it just means you do one step, and you go to the next step and the next step, and it looks like a staircase, or the more preferred analogy here is it's a waterfall. You put water on the top and it rolls off to the next, to the next, to the next, and through a series of rocks down a pleasing cascade of visual, relaxation. Because in reality, when there's problems, it's not quite that relaxing. So that approach works, especially, and that's probably the classic approach. The classic approach has been challenged, and one approach that has often produced better results than the classic waterfall approach is a prototype approach. And the idea on a prototype approach is we're going to say, well, we're building this new system because A, B, C, and D, the things that it does, the value it brings to us, let's just prototype it. Let's just focus on A, the benefit A that's coming from this new software, and let's get it up and running, and not even the whole functionality of A, but just the basic functionality. Right? Because there's all these little nuances and details. What happens on a tax year when you're dealing with interest, push forward data on a something, right? And it can become very complex. But at the core of what you're trying to do is you want to be able to access the data from your phone. Okay? So you can build a prototype. It doesn't have all the functionality of the final system, but it has the basic functionality where, yes, I can read my email from my phone using an app. Right? That would be an example of a prototype. And then that works and customers like it, and then you add functionality, So the first approach is kind of a monolithic, all-at-once approach. This prototyping is much more getting feedback from the end user of the product. And you write something, you say what they like, they say, I don't like this. It turns out that model works very well in industry. That's why it's kind of at least equal to, if not perhaps preferred over the classic waterfall model. There's a third model as well. Oops, I just talked about the classic model and the iterative model, which is prototyping. There's a third model as well, which is talking about really small, nimble approach to software development, which is focusing on the end user and actually giving the end user the tools that he or she needs to be able to request and even obtain the functionality that he or she is looking for. So this end user development approach is small, nimble, app on your phone, really quick, the very opposite end of a monolithic, huge, massive piece of software it takes 2 years to build. It's, hey, what could we put together this weekend that the user would like? Small, quick, nimble, agile. That is an option in software development as well. So all these things are happening right now as part of systems development in industries. Last quick quiz. The first step in systems development is to perform the preliminary investigation. Letter B. Yes, letter B, looking down at answers. Question 2, true or false? The traditional approach to systems development also is referred to as the waterfall model. That's true. That's the classic model. And then 3, a test used to evaluate or measure a system performance is called a benchmark test. It is. I don't think we mentioned benchmark tests in my abbreviated lecture slides, but it is mentioned in the chapter reading as part of the development process. Okay? Absolutely have a fantastic day.